So here we're showing we have 3 network connections on this computer, and each one is sitting on a separate VLAN we created just for this demonstration purpose. So the reason I'm showing you these here is so that you can see that that's how the machine, the computer, the Windows machine is talking to each of those VLANs. We simply put them on each network connection. So that simplifies it for the demonstration purposes. You probably wouldn't do this to an actual server, maybe, depending on how your network is set up, but it allows us to break connections and make them without losing communication to each device. So,
yeah, and it's acting as a.
Go ahead.
I was just saying, and it was acting as a router.
Yeah, and so here we're gonna bring up a couple of the same controllers we looked at before when we were doing DHCP. So we're gonna look at, this is the standalone interface for the Optigo switch, the ONS C401, and we're gonna show here under Layer 2 switching the VLANs that we have in place for these devices to sit on. So we have VLAN 100, VLAN 200, and VLAN 4093 are the 3 we're going to be concerned about for this demonstration purposes. And those VLAN 4093 is what allows me to talk to the switch itself on port 4, and then the other 2 VLANs are what we're going to use to route to the controllers. And we're going to create rules and break them to see how those 2 controllers can talk to each other over VLANs. So here we show at the router, we show the same VLANs because we need them to be there to have the rules. So here we show VLAN 100, VLAN 200, and VLAN 4093. And here they are again under the VLAN section for interfaces. And here we're going to show the rules associated with those VLANs. And in this, we're not really concentrating on creating the VLANs here. We really want to showcase the purpose behind the VLANs, which is segregating traffic, preventing broadcast traffic or other types of traffic from going from one VLAN to another. So for whatever your reason for needing them, we want to show here, we have rules here, the ones that are highlighted, to prevent traffic from jumping VLANs. We don't want, in this instance, we want them to be isolated. So we created rules in the firewall to prevent them from talking to one another. And here's where the ports were assigned on the Optigo switch. And here's where we decide whether we want tagged or untagged ports. And we may want to look a little bit further at this one, Dave. So here, this is worth discussing real quick because this is kind of where the magic happens for VLANs. We have the ones you need to pay attention to here. We have excluded, tagged, and untagged. So we're going to cover those more in depth later when we show how to create VLANs. But really quickly, a tagged port is simply one where traffic that has a VLAN tag on it can be routed to it. An untagged port is where it won't have that tag. So that's really the difference we see here. It's not, and excluded means it's not included one way or the other. You're not going to route traffic regardless to that port. So in this instance, you see we have VLAN 100, which is going to be on port 1, which is FE1, and it's untagged, meaning the devices, the Eclipse controller in this case, it doesn't know what a VLAN is. It doesn't have a VLAN tag. It has no idea. It just sits on the network and plugs into the port. So we have to, the switch has to take care of tagging that traffic with the correct VLAN on behalf of the Eclipse controller because it can't do it itself. So once it's tagged though, if we need to route it to another port, for instance, port 3 or port 4 in this case, we just mark those ports as tagged because once the traffic comes in from the ECY through the port, it picks up the VLAN tag and now it can route to any tagged ports. So it looks a little complicated when you first look at it, but it's important to note that that's how we're moving the traffic when we're taking a controller that doesn't know what a VLAN is and we're getting it into a switch, marking it with a tag, and then moving it around the network that way. And that's how we route traffic. And so here we show the VLAN. So we can select each VLAN and then select the appropriate tags for the ports that we want. Since a port can have multiple VLANs on it. And you see that here, port 3 and 4 have multiple VLANs tagged, but ports 1 and 2 are reserved strictly for VLAN 100 and VLAN 200 because that's where our devices are and they don't need any other VLANs. And so here you see our controllers, one on each VLAN, VLAN 200 and VLAN 100. And we're going to show here we're going to look at whether those two controllers can currently talk to one another or not. And so we'll load them both through a web browser, and we'll use a utility that's inherent to both controllers to test pinging to see if we can talk to each controller. So while we're waiting, and that's really the purpose of this, is to isolate these controllers, because if you have a network with thousands of controllers, if they have no reason to talk to each other, if a VAV on floor 1 has no reason to talk to VAV on floor 2, they should be isolated. So here we're going to try to ping these two controllers. I have too many IP addresses in my head, so. And here I'm in the second controller, and I'm going to ping the first again. So once we have the address, I'll attempt to ping it here. And you'll see there won't be a response. It won't come up with anything because it doesn't have a path to that controller. It can't see it. And the same will be true for the opposite. If I go to the other controller, I won't be able to ping back and forth either. So what we'll do is we'll go to the firewall and we'll remove the rule that prevents these two controllers from talking. So we're going to allow the VLANs to talk to one another. And so I'll disable the rule on VLAN 100, and I'll also disable the rule on VLAN 200 so that we can now, those controllers can talk. And it won't just be ping, those controllers will be able to talk to each other on any port, since there'll be no rule preventing them from doing it. So we're going to demonstrate that here. So now when I go to ping that controller, I can hit it. And I could hit it on any port I needed to at this point, since I removed all restrictions. Although it's worth noting, you still will not be able to broadcast from one VLAN to another. That is blocked. So if you just want to hit port 443 or you just want to do a ping, that's fine, but you won't be able to broadcast. So if you're doing a BACnet discover and you were sitting on VLAN 100, you would still only discover VLAN 100 devices. So here I'm enabling the rule again, and we're going to follow up and we're going to actually create a rule specific to ICMP, so we can just ping and nothing else. So here you can see once I enabled the rule, the controllers can no longer talk to each other. And we'll switch back to the firewall and we'll create a rule really quickly that allows these controllers to simply ping one another and nothing else. So here I'll select my protocol, and then I'll select my destination, which will be the other VLAN.
And just to note, the ICMP protocol is just for ping.
That's it. And there, we'll save those changes, and then when we go back to the controllers now, they'll actually be able to communicate, but they will only be able to ping one another. If I tried any other type of traffic, it would not route. And to the next one. So as you can see, VLANs are actually, once they're established, it's very easy to manage them with some simple rules. It's important to create the rules appropriate to the type of network traffic you need, and not just open them up all the way, because that, in a way, that defeats the security of having the VLANs and the segregation. Because remember, people may be plugging into these VLANs for work purposes, and they also you may have laptops, you may have third-party devices that aren't associated, that are on your VLAN but weren't supplied by you. So you want to make sure the rules there are specific to the traffic you need, and not just create VLANs and then open them up for everything, because it kind of defeats a lot of the purpose behind them, because we're really trying to segregate them from one another for a number of reasons. And when we later in other videos, when we go to create these VLANs and show you how to do that, we're going to cover that more in depth.